And question 3 is finally the time that we see the square root equation come into effect, like we saw at the very beginning, the very first thing we did when we worked together today. Question number 1, it says again, find an explicit equation for the composition function, then state the domain. So this is identical to example 2 in the wording. The only thing different is we're working with different functions this time. So we're going to see how does that work, what kind of effect does that have. So g of f of x. G of f of x, well, f of x is the square root of x. And then what happens in g, whatever you plug in gets squared, and then you subtract 4. So what does this look like? Square root squared just becomes x minus 4. Now what makes this one interesting and a little bit different is when we get to the part that says, what's the domain? Because if you look at your answer, can you see that your answer is a line? And a line's domain is everything. Can you see yourself being very tempted to say, XER, good, done, finished? But if we look through this whole question, do we ever run into a place where we can't do something? Like if I look right at the beginning of the question, where I have g of the square root of x, what happens if you plug in -5 right here? It's bad, because you would take the square root of a negative. In fact, here we can say that no negatives are allowed. And if no negatives were allowed early, no negatives would be allowed later on, because you needed to do that first. And so our domain in this case is x is bigger than or equal to 0. If you were asked to graph this as a final answer, y-intercept is -4. It's a straight line with a slope of 1. But your graph would only have that part of the line when x is bigger than or equal to 0, not the rest of it. So with your domain, even though things simplified to get rid of your square root, you still have to consider the domain throughout the entire question. Looking at part B, which is f of g of x. G of x was x squared minus 4. So as I'm doing this question, sometimes I'm thinking about the domain already. Can you see so far? No problems. I could plug anything into here. That would be no problem. What does f of x do? It says take the square root of whatever you put in. So we would have the square root of x squared minus 4. To figure out the domain is only true when x squared minus 4 is bigger than or equal to 0. How do we solve this? Well, we find out where it's equal at plus or minus 2. Draw your circles, fill them in, and check out where is it true, where is it false. Plug in 0, -4, no, that's false. Plug in -3, that's true. Plug in +3, 9 minus 4, that's true. And so we can say that our domain is that x has to be less than or equal to -2 or x has to be bigger than or equal to 2. And if you were asked to graph this, you would have to go back to chapter 2 and think, how do I graph square roots? First of all, I graph the inside function. I'll just draw that with a dotted line. It's a parabola shifted down 4 units. Would you agree that that's x squared minus 4? How did we graph a square root? We marked where things were equal to 1 and 0 and said, where the y value is 0, it stays the same. Where the y values are 1, it stays the same. Between 0 and 1, your graph is slightly above, and then it's below. So our questions for practice on this one, all of number 6 and 10.